Okay, so today we will prove Pythagorean theorem, but before proving that we need something. We need some prerequisite concepts or ideas about the right angle triangle. So let's discuss that first. So first of all, we need a right angle triangle, and this is a right angled triangle. So in a right angle triangle, as we discussed yesterday, there is an acute angle, and you know what acute angle is, right? So on the basis of that acute angle, we define all the sides, we name all the sides. So on the side on which this acute angle is based, we call it the adjacent side, and we just name it A. The angle, the side opposite to this angle, this side, we call it the opposite side, and we name it as B. And then the remaining side, the longest side of the right angle triangle, let's name it C, which is hypotenuse. So this is hypotenuse, this side is adjacent, and this side is opposite. So now trigonometry is all about the measurement of triangles. So this is now, we are now doing trigonometry. So measurement of triangles, what do we do in measurement of triangles? In measurement of triangles, basically we find the unknown elements of a triangle. So you know what elements of a triangle are? Okay, tell me about it. That's fine. So elements of triangle, there are six elements of triangle. There are 6 in numbers. What are they? 3 sides and 3 angles. This symbol is for angles. So 3 sides and 3 angles, altogether they are called the elements of triangle. So we find the elements of triangle. So how can we find the element? Either we will be finding the angle, or either we will finding the side. So for that we use some functions, and now let's talk about those functions first. So one is sine, the other one is cosine, or simply we can call it cos. The third one is tangent, but simply we can call it just tan. We use these 3 functions, the ratio of these 3 functions, to find the unknown element that might be angle or side. Both, we can find both. So now let's talk about these 3 functions briefly, the ratio of these 3. So the ratio of these 3 that can be found easily using this acronym, SOHCAHTOA. SOHCAHTOA. So SOH, which means sine theta. S for sine theta, theta is angle, we talked about this yesterday, equals, O is opposite, so opposite we named it as B, over hypotenuse, which we named as C. So B over C. This is the ratio for sine theta. Cos is Ka, C-A-H. So C for cos. So cos theta equals, the ratio for cos theta will be always adjacent or hypotenuse. A for adjacent, H for hypotenuse. So we named adjacent as A, and then we named hypotenuse as C. Getting it? That's fine. Then TOA, so T for tangent theta. So tangent theta equals opposite or adjacent, so opposite is B and adjacent is A. So these are the ratio for these functions, sine, cos and tangent, and we use these ratios to find the unknown sides and elements. But we will come to that later. Today the objective is to prove Pythagorean theorem. So in order to do that, we use these functions. That's why I'm telling you about this now. You should remember this one thing, that whenever we try to find the missing side or missing angle of a triangle, we use one of these three functions: sine, cos or tangent. Now you will be saying that no, you're wrong, because Pythagorean theorem don't use any of these, because Pythagorean theorem is hypotenuse squared equals adjacent squared plus opposite squared. This is Pythagorean theorem. So there is no function, we don't see any function, just squaring the sides. That adjacent and base squared, add them, this equals to square of hypotenuse. So now if adjacent is missing, so just make A the subject in this equation and then you can find the value for that. If opposite is missing, then make B the subject and then you can find the value for B, the opposite side. Or if you want to find the hypotenuse and adjacent and opposite are given, then just take the squares of both the sides, add them, that will be the value for hypotenuse. So there is no use of these functions. So basically this theorem is derived using these functions. That's why I always say that these three functions are used to find the unknown element of a triangle. Okay, so now let's get to proving. So in order to prove the Pythagorean theorem, we use these two functions, sine and cos. So let's take these. So sine theta equals B over C. B means opposite, C means hypotenuse. Okay, so now what I'm going to do is to take square on both the sides. So square both sides of this function, of this ratio, the ratio of this function. So then the left side will be sine squared theta equals B over C whole square. So square will be on both of them separately. So that will be B squared over C squared. Let's say this is one equation. Let's name it as equation 1. This is equation 1. Now let's take the cos theta. So cos theta equals A over C. Let's take square on both the sides. So cos theta whole squared is cos squared theta. Square cannot be on angle, only on the function. Cos squared theta equals then A over C whole squared. So square will be on both of them separately, which will make them A squared and C squared. Let's say this is equation 2 now. And now the next bit is very interesting and important, because now we're gonna add these two equations. So how can we add two equations? It's pretty simple. Equation always has two sides, left hand side, right hand side. So left hand side of one equation will be added to the left hand side of the other, and then side will be added to the right side of the other. It's that simple. So now let's add equation 1 and 2. That will be left side of one equation, which is sine squared theta, add cos squared theta, which is the left side of the other equation, then equals the right side of one equation, which is a squared over c squared plus right side of the other one, which is b squared over c squared. Okay, now in the next step we will talk about this identity in the future, inshallah. Square theta plus cos square theta is an identity, is a formula which equals 1. We will also inshallah prove this identity, that why this equals to 1. So 1 equals, here we have two fractions and they have the same denominator, so can we add them? Can we add them? How? Exactly, so we'll just take one denominator as common and then we will add the numerators directly. That's how we do it, right? Okay, so now here we can make the c subject. This one has the 1 in the denominator, so we'll just do cross multiplication like this. So c squared times 1 is c1, right? What is it? Just c squared, yeah, just c squared. We don't need to write down 1 because writing 1 is meaningless. There is always 1 as a coefficient. And then 1 times a squared plus b squared is, oh, squared is missing there. Okay, so a squared plus b squared. So there you go. This is our Pythagorean theorem. Proved. So now we will use this theorem to find the unknown sides of a triangle. Let's practice an example. So now we have this question. Let's name the sides first. Let's say here we have our acute angle theta. So this side will be then adjacent side. This will be our opposite side. And this will be our hypotenuse. And then we can name or adjacent anything we want, but usually we do as A, B and C. Now let me write down the Pythagorean theorem, which is c squared equals a squared plus b squared. What are we required to find? The hypotenuse side, that is missing. The adjacent side is 7, the opposite side is 3. And now we need to find the hypotenuse, so we can find it in this Pythagorean theorem. So c squared equals a squared, a is 7, so 7 squared, plus b squared, so b is 3, so 3 squared. Okay, then c squared equals 7 squared, which is 49, plus 3 squared, which is 9, and then 49 plus 9 is 58. So c squared equals 58. We need the value for c, not c squared. What should we do here to get c? Think. C squared equals 58, not c. How can we get c then? How can we get the value for c? It's simple. You just square root both the sides. So square and square root will cancel each other, and then you'll get c. C equals, what is the square root of 58? So square root of 58 is 7.6. So this is our hypotenuse, 7.6. Let me write it here. 7.6 is this side. and this is the required answer. Got it? That's good. Okay then, that's all. Thank you.